So what we're talking about is CLI managed switching and getting better visibility out of that switching. We have this Meraki dashboard that you're all aware of, and a lot of people avoid Meraki because it's OpEx. You have that subscription license, but we can leverage this existing dashboard with our already bought DNA licensing to at least get visibility. Maybe not management, but we'll have the telemetry visibility that really benefits us when we're troubleshooting. First off, a little bit about me. I live in Minneapolis. I'm from this area. I grew up in La Crosse, born in Madison. I was a teacher. I was a bartender. I was a retail director. I've been a whole bunch of things. But then I was working for Herberger's and it went out of business back in 2018 or 2019. I was the director of Minnesota's stores. And I decided to just make a career change. I went back to Hennepin Tech. I got a cybersecurity certificate, and then I acquired my CCNA, and it was off to the races. So I'm married. I have one dog, 3 cats, and I've been at Cisco for about 3 years now. So yeah, let's go on to the next one. So network management, that's what we're talking today. And CLI has some just intrinsic difficulties. First up, it's operationally burdensome. Every device is its own island, so an org-wide change requires either scripting, Ansible, or an SSH session to each device. And then troubleshooting requires flipping back and forth between PuTTY sessions. Then there's config drift. And yeah, we have text files that we use to manage our devices, and we just copy and paste, but it's hard to know like which one's the latest. And I don't know about you, but I had a folder full of different device text files that I maintained that had different dates for all the devices, and it was kind of a mess to manage. Another problem with CLI is that there's tribal knowledge and also configuration bloat. I've seen switches before with like 5,000 lines of configuration, and we're going through them and we see this ACL and we're like, what is this ACL for? And nobody can tell. Like, they have no idea what the IP addresses are going to. But the number one problem in my mind is that managing firmware versions is incredibly difficult through CLI. And it's more and more important every day that we maintain current maintained versions to address all the vulnerabilities that come up. And Cisco is very vocal about our vulnerabilities. If we have one, we wear it on our sleeve, we send it out to our customers, we let you know. And then we work on patching it. And that patching can be very difficult from CLI. Then there's also limited context. CLI gets you data points, not insights. There's no easy way to see like multiple device patterns or historical issues. And then again, you're jumping from logs to SNMP logs to ARP tables to CAM tables, CDP. You're doing all these different commands, and you have to do the correlation. With a controller, that can kind of take over a lot of that intellectual like lift. And finally, with CLI, changes can be risky. Manual configs introduce human error. There's a lack of version control. Rollback is manual, and it makes it hard to maintain standards across multiple stacks and multiple devices. A CLI change can easily take down a network. I don't know if any of you have ever done switch port trunk allow VLAN add, and then you put the VLAN number in. But if you forget that word add, you're basically flipping that trunk back to that single VLAN that you're trying to add, and you'll take down everything. So it's risky. And you know how I used to manage my configurations? I managed them with this. Notepad++. Who here has used Notepad++ before? They have a compare function here in the plugins where you can look at one against the other. And then we have to search for like our lines to see where our difference is. This is the same switch. On the left, I have a Catalyst. It was managed by Catalyst Center back in December. And just in January, I flipped it over to the CLI management with the Meraki dashboard. And you can see all the differences between these two configurations. And it just gets to be too much to manage. So, but we have network management tools. We have SNMP. Many people use PRTG. Many people use SolarWinds, those types of tools to maintain like up, down, and get alerted on SNMP traps. Problem solved, right? Well, not so fast. SNMP-based monitoring tools, they definitely have a place in our networks, but they kind of fall short of complete visibility. Often SNMP relies on periodic polling, which doesn't give you real time, and issues are often detected late. Now, it does have traps too, and that's more real time, but it's limited in its device context. It basically exposes counters without understanding the users or the applications or the root cause that's behind that counter getting tripped. Additionally, SNMP can scale kind of poorly, generates overhead if you're putting it across your whole network, and it lacks modern capabilities. So the truth really is that SNMP is a useful tool that was built for a different era, which kind of makes it a little insufficient to handle today's dynamic and high-density cloud-connected networks. And this is where controllers shine. Managing a network through a controller like a Catalyst Center or a Meraki Dashboard is beneficial because it gives you end-to-end visibility across your environment, automation, consistency, and audit trails that CLI it just doesn't do for us. When the controller serves as a single source of truth for the configurations, for the policies, for the telemetry, it eliminates that drift, it eliminates the human error that comes from managing one device at a time. So then there's the real-time traffic analytics, AI-driven insights, automated troubleshooting. These help teams detect issues before the users really feel them. And it's something that CLI alone is not really designed to do. That ability to visualize client health, application performance, security posture, and network topology all in the same place, that reduces your operational overhead. It makes troubleshooting quicker and speeds up root cause analysis. So ultimately, controllers shift network management from box-by-box configuration to proactive, scalable, data-driven operations. So we have Catalyst. We're talking Catalyst today. What options do we have for managing our devices? First up, there's the on-prem Catalyst Center. This is an enterprise-grade network management and automation platform that gives full lifecycle operations. It gives assurance, AI ML insights, closed loop automation, and it's really ideal for organizations that need deep visibility. It does SD access, which is a fabric implementation with an overlay and an underlay. It has designing, templating, compliance, and it's used for large-scale wired and wireless management. The second option is Cloud Dashboard with cloud configuration. We called this Meraki. We change our names every couple months. There's a new acronym or a new name change for one of our products, so it's hard to stay on top. But it didn't make sense calling it Meraki anymore because now we're using Catalyst devices in this Cloud Dashboard. We're not using the Meraki OS, we're using iOS XE in this Cloud Dashboard. So it makes sense to change the name. But this is full-based management within the dashboard of Catalyst switches and APs. It includes the configuration, click configuration, monitoring templates, and it's best for teams that want a centralized cloud ops, simple provisioning, and consistent configuration workflows. It uses iOS XE, not Meraki MS, and it can also do spine and leaf fabrics like a BGP EVPN fabric. So then we have the third one. This is what we're doing today. Think of it as controller light. It provides cloud-based monitoring, topology, client visibility, and alerting for Catalyst devices while maintaining local CLI and GUI-based management of the configuration. So the cloud is not pushing configurations, it's only ingesting telemetry data and then displaying it for us. Controller light. And it's available with iOS XE 17.15.3 and up. Then we have third-party automations or scripting, Ansible and Python. Those are very popular options around, especially our higher education customers. A lot of the schools use those. And we also have Web GUI, box by box, and we have CLI box by box. So what are we going to do today? We're going to do cloud visibility with device configuration. It's just these 5, really 4 steps, and that's all it takes. First, we enable Service Meraki Connect. This creates what we call the next tunnel. It's just a TLS management tunnel that connects to the cloud dashboard. So the switches use this TLS management tunnel to connect to the Meraki cloud when operating in device configuration mode. Now this tunnel is only designed for control plane traffic. It carries netconf as the primary mode of configuring these switches. It also carries the event logs, the telemetry, but no user traffic. 0 user traffic crosses this TLS tunnel. All that user traffic goes out however you've designed it in your own network. This is an outbound TLS session from the switch to the cloud, and it's turned on with this single command, Service Meraki Connect. And it requires an active outbound HTTPS firewall rule, so we have to let the traffic out. The second command is Show Meraki Connect. This gives us the details of that tunnel that Service Meraki Connect spins up. And it also gives us our claim code that we use to claim the device in the Meraki dashboard. After we get that claim code, we're going to log into the dashboard, we'll claim the device, we'll assign the device to a network, and then we'll watch as the dashboard pushes configurations to this switch that allow the telemetry to pass. That's all there is to this. So it's basically one command, grab a claim code, claim it in the dashboard, assign it to a network, and we're done. But a lot happens under the hood. So we're all engineers. We kind of want to know, well, what is it really doing? How does it really get that telemetry up there? So let's go through the configurations that will be pushed by the dashboard through that TLS tunnel. First up is our access. It creates local AAA method lists named Meraki for Auth-C login, and then authorization executive privileges. And this is so that the netconf and the Yang sessions authenticate and authorize against a local user. And it depends on the version of netconf Yang. Sometimes netconf Yang uses the default method list instead of Meraki, but this requires 17.15.3, so it should be the Meraki AAA list. It also makes 4 users for the dashboard, and these are used for the dashboard to log into the switch and make configuration changes or monitor the telemetry configurations. And then it creates and applies a pair of access lists so that only TCP traffic on port 2222 between these two very specific IPv6 blocks, that's applied to the VTY line so that the only thing that can access this switch is from those IPv6 addresses over 2222. And then it adds a static discard route, ensuring that any stray packets that get routed to the prefix are dropped rather than forwarded. The next thing, we did access, now we have to do our SSH connectivity. And the dashboard will push SSH version 2. It will limit authentication to a public key or a password as allowed methods for authentication. It binds the SSH port 2222 to the rotary group 55, and then associates a specific public key to the Meraki user for key-based authentication. After that, it enables LLDP for neighbor discovery. It needs an HTTPS server enabled with a local user authentication for web REST-conf and GUI access. And then on lines VTY lines 32 to 35, it'll require SSH. It applies the previous built access lists, the Auth-C and Auth-Z method lists, and then it applies the rotary 55 group, meaning that port 2222 that we configured will only be open on these VTY lines, which also have the previously defined ACLs and method lists. So this is really locking down that, hardening that security of the VTY line. Then we get into the interesting stuff. So the device tracking is what helps us maintain our IP to MAC bindings in the table. Device classifier, that top command, this enables the device classification framework, which is also called DCP-SDP. And this is so the switch can identify endpoints and contexts. So it can identify if it's a phone, if it's an AP, if it's a printer. And it does this using multiple signals from LLDP, CDP, HTTP, and MDNS. So it kind of just listens to those things and gleans the information so that it can classify the device. It also makes 2 device tracking policies. These are to be applied on different types of interfaces. You can see one is listed as access, one is listed as trunk. In the track policies, we set a limit on the size of the IP device tracking binding table. This is a guardrail against floods. That's the limit address count line. The next line, security glean, this tells the switch to passively learn bindings from L2 and L3 control traffic. So it's one command that basically does ARP, neighbor discovery, and DHCP snooping, and builds a table out of that. And then tracking enable, the last command, that actually turns on the tracking and starts the building of the table. So if we don't have that on there, it won't build the IP device tracking table. And then the third policy, this is for ports that we don't want to track, common for cloud management control ports or out-of-band management ports, uplinks, special infrastructure links where tracking can just introduce noise and doesn't give us any benefit. Like I would not track on any of my core ports. I would track on my distribution and my access layer ports. So these device tracking policies, they're actually applied on the interface. So that we'd be in an interface and we would say IP device tracking attached policy, Meraki access track. But there is a caveat that an interface can only have a single IP device tracking policy configured on it. So some of us may be managing Catalyst Center as well. If you run this onboarding on a Catalyst Center managed switch, the Catalyst device tracking may be overwritten by the Meraki device tracking, which means we'll lose that visibility in Catalyst Center. Just something to be aware of. Next up, we have a bunch of traps that we configure for SNMP. SNMP is an older protocol, but it does still have a place in our networks. And here we configure a trap for any kind of write memory. That's that first line, copy config, run start. Any configuration change, that's the second line. We want a trap for the configuration tracking ID so that we can correlate configuration events. And then we want a trap for our syslogs. After we configure the traps, we have an SNMP server that gets pushed. That is the Meraki cloud where we're sending these traps. And then we do logging. Logging history informational means that the buffer will fill with any log severity that's higher than informational, so 6 through 0. But we don't need the informational in the Meraki dashboard, so we're only going to trap errors, warnings, emergencies, alerts, and critical. Those get sent to the dashboard. All right, and then the last up, probably the most important part of the configuration. It creates a handful of NetFlow, flexible NetFlow configurations. And what flexible NetFlow is, or FNF, it's Cisco's customizable traffic telemetry framework that lets you define exactly which flows between L2 and L7 the device captures and exports so that you can build very precise visibility and analytics tailored to your environment. Flexible NetFlow has 3 components. There's a flow record and a flow exporter and a flow monitor. The flow record defines what constitutes a unique flow by matching criteria. So up here we have match application name, match interface input, match IPv4 source address. If any one of those changes, it's considered a new flow and not a unique flow. So with the record, it'll track those pieces of information, that application name, the IPv4, the interface input. It'll also track the collect stuff, collect the counter bytes, counter packets, data link MAC destination address, flow direction, and the VLAN. The match is required for making the unique flow. The collect is extra information that we send to the dashboard from that flow. The next item is the exporter. This is the destination where we're sending the NetFlow information. And here we have it destined for a rotating local repository, which is then queried by the cloud dashboard over that TLS tunnel. This local file export default is configured as well. So it's configured with like 2 files, it erases every 5 minutes, and it doesn't include a bunch of specific NetFlow headers. This is to keep the overhead low on the NetFlow operations because NetFlow can overwhelm a switch if it's configured too heavy-handedly. So this approach keeps the NetFlow processing requirements to a minimum. The last piece is the flow monitor. And this is the command that ties together a flow record and a flow exporter, puts them together, and puts it on an interface. Nothing will be monitored until a flow monitor is applied on an interface. An interface can have up to 4 flow monitors as well. And different flow configurations are pushed for different use cases. This is one flow monitor configuration, but there's actually 3 of them configured. Those are listed on the right side here. If you look at the bottom one that says TA2 HTTP SSL, this is an application visibility and control flexible NetFlow. They also call it AVC FNF. And that just means that it has an additional set of criteria that it can match against and can collect over traditional flexible NetFlow. And this includes, it tracks the client IP, it tracks the server IP, the bytes and the packets from both sides, the direction of the flow, the ingress and egress interfaces, and the timestamps. So it's a heavier NetFlow configuration that gives you more detail into the actual application and client and server side communications. If we ever have trouble in our Meraki dashboard, seeing the applications and the flow data, it often has to do with these NetFlow configurations. And there are a few other commands that are applied to the switch, but these 5 slides that we just covered are the meat and potatoes of how the dashboard receives that telemetry from your switch over the TLS tunnel. That was a lot of information. Are there any questions before we continue on to the next slide?
You mentioned that if we have any issues with seeing telemetry data on the cloud, it's most likely related to these configurations for the NetFlow, flexible NetFlow. Is that because sometimes they fail to be populated automatically? Because I'm assuming we're not touching this, right?
Right. This is generated automatically from the dashboard, and it has templates of what types of devices should receive which NetFlow configuration based on best practices. I had mentioned that we don't really want NetFlow on our core switches, so it's not going to push any NetFlow to the core switches. If I did want to put NetFlow on that core switch, I could just copy it from my access switch, paste it on my core switch, and that data will show up in the dashboard. But it gives its first deployment is kind of just best practices deployment, generic best practices deployment. Your environment may have more specific needs. I have run into trouble. I've been importing and deleting these switches from this dashboard like left and right the last couple weeks. And there were a couple times where I didn't fully remove it. And then I tried to import it. And it did have a problem with the import. But the dashboard itself will give you alerts as to what the error is that's preventing correct data from hitting the dashboard. And you can follow those breadcrumbs to kind of get to your solution. And also call me, because I've done this a dozen times now. So any other questions? All right. Well, let's take a look at the configuration we're going to do today. This is the environment. Now, this isn't so important, but I wanted to give you a glimpse of the network that I'm actually working on right now. I run 3 different stacks. On the far right side, that's my Meraki managed, fully Meraki network. On the far left side, this is my Catalyst Center network. I have a 9500, a 9300, and some 9130 AP. This is managed by Catalyst Center. In the middle, I have basically the same stack, 9500, 9300, 9130. That's managed via the CLI, and we're going to import it into the Meraki dashboard today. I'm currently connected right now to this AP in the blue box on the bottom, and we're going to be performing this configuration on this core switch in the red box on the top. So if I lose connectivity, I don't think I'm gonna, but if I do, it's, yeah, not unexpected. But this configuration isn't supposed to, it doesn't affect data path. You know, it creates these metadata files that it then forwards on to the dashboard. So it doesn't actually manage any of your data path traffic. So it shouldn't affect any of my connectivity as we do this. All right, so let's get to it. I'll pull up my dashboard. If anybody is following along, now is the time to log into your switch and into your dashboard. I have my dashboard up. I'm on the organization overview page, and I can see my 2 networks. And here on the right, I have my 9500 switch that we're going to be importing today. If I run a show Meraki connect, well, it already has it enabled. Let me conf t no service Meraki connect. There we go. Now show Meraki connect, we can see that the service Meraki connect is disabled right now. So there's no TLS tunnel to the dashboard. To get started, we want to enter conf t, and we'll enter the command service Meraki connect. I'm also going to do a term mon so you can see the connections come through as they happen. But now if I run show Meraki connect, I can see the status of this TLS tunnel that's being created. Oh, and a bunch of stuff just came up. Here's the show Meraki connect, my fetch state, last fetch time, IP addresses, tunnel state. It starts off as down, down, but should come up. The status should be enabled. And then the most important piece of information in this command is this claim code right here under Cloud ID. So we're going to copy that claim code because that's what we use to claim in the dashboard. If I try it one more time, I think those tunnels will be up now. Yep, here we go. Primary up, secondary up. Okay, so this guy's ready to claim. Let's flip back over to our Meraki dashboard. And I'll go to organization. And I'll go to inventory on the right side. This is where we claim devices. In the inventory page, you can see a whole bunch of devices here. Like I said, I run a Meraki network as well. If I want to look at my 2 different networks, I can click the dropdown. Cleveland is my Catalyst, Victory is my Meraki. Back in the inventory, we can claim devices on the right side. We take that claim code we got and we just pop it right in and we click claim order. Now the device is in our inventory. I see it here at the bottom. It has that same claim code I used, the same serial number. It shows the correct version and the time is right now. Next thing that we do is we assign it to a network. And once we assign it to a network, then it starts pushing all this telemetry configuration that we went over. So we have the box open here on this side. We'll kind of see the telemetry push in the background over here as we do this. So up at the top, I've checked the box for that switch. We're going to add to network. Very important. You can choose either an existing network or a new network. If you haven't created a network yet, choose new network. I have one, so I'm going to choose Cleveland School District. Here, it'll ask if you want to do device configuration or cloud configuration. With the 9500 that I'm doing, it only does device, so it just gives me this option. But this is very important. Do not choose cloud configuration. It'll turn it into a cloud managed device, which will then require a license. And we're just testing this out. We're just testing the visibility. So do device configuration. Enter your username here. I have a generic user switch admin that I like to use. My super secret password. Select the checkbox, terms and conditions, and click next. It'll have us review our device, the configuration source, device. That's that important thing. We do not want the word cloud right there. Management mode cloud is fine. And then we add to network. And that is all it takes. Now, there's another 15 minutes that are going to pass. And over that 15 minutes, the dashboard is going to log into the switch a few times, and we'll see a bunch of netconf messages saying that it's changing configuration. So we'll watch that on the right side. And in the meantime, I want to show you what visibility we gain. So I have a switch that I already put in here. It's my access switch. If we look at the network diagram, oops, let me just back up one page. There we go. This switch in the middle is the one we're looking at right now. I've already imported that into the dashboard. It's called CMS 9324. We can see our switching from the switching tab, the switches option. That brought me to this page where I see my existing switch, and I also see my new switch that was imported. We can tell by the claim code. While the new switch is coming up, let's take a look at this existing one. And we can see the new switch is getting configured over here, all those automated configurations. But here's what we really gain from this dashboard. First, you have a summary page for your switch. This gives you a bunch of vital information on the left: location, serial number, claim code, uptime. We have our firmware, we have our IP, we have our gateway, we have our DNS. It's all right there. Up at the top, we have an image of the ports, the ups and downs. These are all disabled ports in the gray. But I have 3 ports up. This is my uplink. You can see the auto-negotiated speed. You can see the VLANs, native VLAN. Here's an access port I have to that laptop that's running right there. It's running stuff on it right now, YouTube or something. 1 gig. Here I have my AP connection. The AP is underneath the bottom there. That's a 5 gig connection. Below that, I can also see my connectivity history along with the usage of this switch and the throughputs. And below that, I have all the clients that have come through the switch. The IP device tracking policy that we had gives me all this information, sends it up to the cloud for it to be displayed here. I have VLANs, I have ports, IP addresses, MAC addresses. That's the summary page. Going over to the ports page, it gives us a table of our port config. So if we wanted to compare interfaces side by side, we could do it right here from this table. It includes things like LLDP, CDP neighbors, and bytes, throughput, all sorts of information that's useful as well. But I think this is probably one of the biggest game changers is the CLI, Cloud CLI terminal. So I'm in the dashboard in the cloud. I can click Launch Terminal, and it will create an SSH session through that TLS tunnel to this switch. And this switch, this SSH session on the 3rd line here, I'm in config mode. That means I could do a conft, I could do a do show IP int brief. You know, I can do ping 8.8.8.8. I can even do interface configurations. Interface 1.0/23. This is 10.10.23. This is that laptop right here that I'm on. I can just shut that interface, and that will effectively kill internet traffic to that device. I can no shut. I can end. On Monday, I took this exact switch and I upgraded from 17.15.3 to 17.18.2 directly from this Cloud CLI using 1 command. And it just went through the upgrade process. It activated the new version, it committed the new version, and then it was on 17.18.2. So it simplifies firmware image management. Let's close that terminal though. It's super cool, but we can CLI through SSH as well. Below it, it keeps a history of all the configuration changes I've made. I can download the session log. I can open it right up and look at exactly what configurations were done. This did a show version, and then I have conft. I did the same thing, shutting that port. It provides a centralized spot for all your audit trails, also very useful. Then down below, we have automated show commands that we can just run. So let's say I'm curious about my LLDP neighbors on my AP port here. I just run that. I don't even have to type in the commands myself. It just does it for me. And if I look down here, I see the port, the AP port is gig 0, the AP name is CMS AP 9130, the version is 8.17.18.1. Great information, really easily accessed. Next up is our device health tab. This will give me an overview of the power supplies, if there's stack power configured, and also the PoE consumption on this specific switch. We can see I have one power supply, it's an 1100 watt, and I have no stack power configured on this guy. And I'm using basically 12 watts out of a 30 budget that's on there. And then it shows my PoE neighbors. Here are all my PoE devices on this switch. It's just the one, but it's cool. Event log. You know all those syslog traps we configured? Boom, there they are, right here in the dashboard. So this is basically a shared syslog for all of my devices. Location is easy. This just lets you put it on a map somewhere. You can put a photo of the device in as well, and then also check the topology of the device. Here's my switch. Here's that new switch as it's coming up. It's not fully up yet, but it's there. Imagine if you had your entire switching infrastructure in here. You could see all of your connections between your entire environment in like one visual image. I know how much trouble it is making visios and diagrams. This can help with that. The tools, standard tools, ping, cycle port, MAC forwarding table to see what MAC addresses are out, which ports. And this last bit, config history. This is useful as well. It keeps track of the last week of config, and I can compare them. So if I make a change and something doesn't work and I want to try and troubleshoot it, I can compare configs. I can put this back a week. And just like in my Notepad++, I have red-green on the right side. That'll show me device classifier. Oh, that's because I imported it into the Meraki dashboard. You can compare the configs right here. You can download them. You can copy them. I could copy it right here, move over to the Cloud CLI, paste it in, and update the config that easily. So this is like in one switch. Let's take a look at that other switch that's come out. I just imported this. It's been about 10 minutes, and we already have the SNMP up-down data. We have the connectivity history. We don't have usage, and we don't have clients, but that's by design because we don't want to double track our clients and our users on the network. We don't want an endpoint showing up on two devices when it's really connected to the access switch. That's one of those best practice flexible NetFlow configurations. But it's not just about the single switch. It's about being able to correlate information across your entire environment of switching. So if we come to the Network Y tab and I click on clients, I can see all the clients that are across my entire network down here, along with their IP, their MAC, their usage, device type, last seen, connected switch, VLAN, just great information. Under topology, it's that same idea of the switch topology. I only have two switches, so it's kind of boring. And then intelligent capture, this is super cool. I can run a PCAP on any of these switches directly from this dashboard. I can select the switch. Let's do it on my 9300. Let's do it on an AP interface. We're just going to do 5 seconds because let's not even do 5. Let's do 3 seconds. Let's start the capture. We can save these captures in the cloud. It'll save 10 captures rolling for you. We can download these captures. We can view them in Wireshark. We can treat them however you treat your regular PCAPs. But we don't need Wireshark. It'll actually let me view this capture directly here in the Meraki dashboard. And there I go. A whole bunch of syslog messages. Wonder if there's anything else. Yeah, some other data here. There we go. But it keeps us from having to flip one more tool to get this information. And then under network-wide event log, this is an aggregated view of all my switching logs. So it won't just be that 9300, it'll be that 9500. Because I'm curious if what happened on the 9300 has anything to do with the 9500. I want those syslogs right next to each other in terms of chronological order. I can filter by them, whatever condition I want to enter in my filter, I can do that and only look at SSH sessions, etc. Really useful. Yeah, so that's like the basic use cases of the dashboard and the visibility that we have. But there are other things that are included with your free dashboard that you can leverage. One of them is the Cisco AI Assistant. The AI assistant is trained. It's our generative AI tool that's tied to our deep networking model. Cisco has an LLM that's aggregating all of our anonymized networking data in order to train this model so that it can give accurate recommendations for resolution and remediations. And it's tied into this network. So now that I have a couple switches in here, I can see if it'll answer the questions about those switches. So let's say I'm curious about a VLAN. What VLANs are configured on CMS 9300-24UX? Now bear with me because Gen AI can go off on its own sometimes, but we're trusting the demo gods today that they're gonna look out for me. Hey, look at that. So here I asked it what VLANs are configured on this switch. It popped out a list of all the VLANs along with the ports that they're configured on. And then it did a summary of it in a table format for me. I mean, that's saved me time from having to log in to ask to run the command, show VLAN brief, and then to like parse through the output to determine which ports had which VLANs. The other cool tool that comes free with the Meraki Dashboard, we just give it away, is the workspace. This is the automation tool that's built into Meraki. I did a workshop on this a couple of months ago. Some of you might have been there. But basically, we can create automations for anything that connects to a REST API or anything that has an SSH. We can automate with it. So that's not just Cisco. That's anything that has a REST API or an SSH. If I log into one of these, we can view the workflow. This is the workflow space. It has a whole bunch of pre-created activities. These are like actions that we can just drag out over here and drag and drop into place to make the automations work. We have to configure the passing of the data between the objects. But once we get that done, you have a pre-built, validated automation. Yeah, thanks, Jordan. Yeah, device configuration all the time. You'll have to call TAC. If you do claim a switch with cloud configuration, it does take a TAC call to get it back to device configuration. So back here in the workflow, we now have our switches in here. We have SSH access to them. We can automate these iOS XE switches from this cloud dashboard using that information. And even beyond that, we can use the AI assistant to call automations from the workflows dashboard. Here I have one for my Meraki network, create network appliance VLAN. This is a very simple automation. It creates a VLAN, but let's just try and give it a go and see if we can call it. Can you run the workflow create network appliance VLAN? Now, usually it confirms with me. It'll look through the automations and it'll see if it has one that matches, and it'll ask me, is this the one? Yes, confirm, proceed. Now it's going to ask me for the inputs that automation requires. You could configure your automations to, not need inputs or to get inputs from a CSV file or from some other source of information. But for this purpose, we're just going to manually enter it. I'm going to call this, let's call it Cloud VLAN. And it'll be 10.1.49.1. The VLAN ID will be VLAN 49. Then the subnet will be 10.1.49.0/24. We don't need the VLAN pool, so I'm just going to continue. It confirms the parameters that I entered. Yes, confirmed, proceed. I try and use the verbiage that it puts towards me back towards it to just help it not get confused. Oh, it failed on me. Let's try it one more time. And while we're running this, I'll also mention that the workflow here has logic, and this is what helps with the bulk configuration applications. We can do for each loops, we can do if-then logic, and using these, we can iterate through an array of your device IDs to make the configuration change on all of your devices. Well, the demo gods didn't look down on me on that one, but we tried. I did do it earlier, and it worked with my Victory network I created a VLAN 44 test. I'm not sure if it's still in there, but all right. So all this stuff, it just comes along with your DNA licensing. It's part of 17.15.3. And you can do it today. Device configuration source, always. Different configurations are pushed to different switches based on the roles. Access will get the NetFlow, or will not get NetFlow, but you could put it on there if you wanted. Only one device tracking policy per interface. Unfortunately, Rick, no to the 17.5 code. This is specific to catalyst switching 17.15.3 and above. So you can do it on 15, 18, yeah. So the restrictions, first one, 15, 17.15.3. You do need the Meraki dashboard. You have to have outbound internet access from the switch. It works on 9200s, 9300s, 9500s, 9610. And I'm talking the L model. I'm talking the CX model, whatever you want to do out of those models, it'll work. It does have a couple commands that it requires, which is a AAA new model, IP name server, and then IP domain lookup and NTP server. And you have to have a local user that initially is used for the onboarding. Once the switch begins onboarding, it'll create its own users to use. But you saw when I initially onboarded, I needed that switch admin user with the password. These are some good troubleshooting commands that help me whenever I hit a wall. And I mentioned that the dashboard will tell you what is failing if something is failing. And it'll say, go check this out. It'll say, your switch already had AAA configurations that it was unable to overwrite. Please delete those and let it proceed. That has happened to me. So if you do hit a wall with this, just reach out to me and I'll hop on with you and we'll figure it out. And then the last thing, I have a bunch of resources. This PDF is attached to the meeting. You guys are all welcome to take it and download it. These are the documents I use to prepare this presentation and what I use to review to do the configuration. So with that, I'll just say any other questions, feedback, love it, hate it? I'll take your silence as approval. Yeah, thanks, Rick. Yeah, I think it's pretty useful too. I'm going to build out more automations as well because I kind of want to test the waters to see how deep I can go. And I'll keep you all posted on that. I'll do another workshop next week on a different topic. If you have any topics that you would love to see covered, just shoot them over my way and I'll do some research and I'll get those invites out. But otherwise, I just want to thank you all for joining me today. And if anything comes up, reach out to my contact info. All right, thanks, everybody.